Hi everyone, I'm here to discuss some topics of the language of mathematics by Keith Devlin. What is mathematics? You are likely to receive the answer, mathematics is the study of numbers with a problem as to what kind of study they mean. In fact, the answer to the question, what is mathematics, has changed several times during the course of history. Up to 500 BC or thereabouts, mathematics was indeed the study of numbers. This was the period of Egyptian and Babylonian mathematics. In those civilizations, mathematics consisted almost solely of arithmetics. It was largely utilitarian and very much of a cookbook nature. The period from 500 BC to AD 300 was the era of Greek mathematics. The mathematicians of ancient Greece were primarily concerned with geometry. With their emphasis on geometry, mathematics was the study of numbers and shape. Next is making the invisible visible.
Is it possible to see the invisible?
Making the invisible visible. We have answered the question, what is mathematics, with the slogan, mathematics is the science of pattern. There is another fundamental question about mathematics that can also be answered by a catchy phrase. What does mathematics do? By this I mean, what exactly does mathematics give you when you apply it to the study of some phenomenon? The answer is, mathematics makes the invisible visible. Let me give you some examples of what I mean by this answer. Without mathematics, there is no way you can understand what keeps a jumbo jet in the air. As we all know, large metal objects don't stay above the ground without something to support them. But when you look at a jet aircraft flying overhead, you can see anything holding it up. It takes mathematics to see what keeps an airplane aloft. In this case, once that we see, the invisible is an equation discovered by the mathematician Daniel Bernoulli early in the 18th century. While on the subject of flying, what is it that causes objects other than aircraft to fall to the ground when we release them? Gravity, you answer. But thus just giving it a name doesn't help us to understand it. It's still invisible. We might as well call it magic. To understand gravity, you have to see it. That's exactly what Newton did with his equations of motion and mechanics in the 17th century. Newton's mathematics enabled us to see the invisible forces that keep the earth rotating around the sun and cause an apple to fall from a tree onto the ground. Aristotle used mathematics to try to see the invisible patterns of sound that we recognize as music. He also used mathematics to try to describe the invisible structure of a dramatic performance. Probability theory and mathematical statistics let us predict the outcomes of elections, often with remarkable accuracy. The last topic that we are going to discuss is the two men who invented calculus. Calculus was invented at about the same time by two mathematicians working independently of each other, Isaac Newton in England and Gottfried Wilhelm Leibniz in Germany. Who were these men whose mathematical insight was to change forever the way men and women lived their lives? Isaac Newton was born on Christmas Day 1642 in the Lincolnshire village of Woolsport. In 1661, following a fairly normal grammar school education, he entered Trinity College, Cambridge, where, largely through independent study, he acquired a Master of Astronomy and Mathematics. In 1664, he was promoted to scholar, a status that provided him with 4 years of financial support towards a master's degree.